let's go straight to the intro. So I'm Gerard Sanz, Google developer expert. And for the last 2 years, I've been speaking at conferences and doing trainings full time. Next week, I will be doing a training in Toronto. So that's the dot there at the top left. And I'm almost there for the 100 talks. So this is helping getting closer. Next week, I'm also going to do a couple of talks at meetups. And I'm going to cover comparing Apollo client with Urkel and also NGXS, which is a new state management library. So if you want to follow that, I will share my slides after the meetup. I'm also a blogger, so if you want to follow any of my talks, you can go online and see any of the topics that I cover in a little bit more detail. Today specifically, I have a few blog posts that will cover animations in more detail, so I recommend you to look at those. Here, this is a special moment for me. This is the publication in Medium, and one day I had all my blog posts featured there at the top. I didn't Photoshop this. I mean, it's very easy, but I didn't do it. This happened. I'm also a community leader, so I run a couple of communities back in London, where I'm settled. And here's Angular Zone. So I'm basically an Angular specialist. And just recently, like 1 year ago, I created GraphQL London. And GraphQL is a technology from Facebook, and it's really picking up. So it's kind of a modern alternative to REST. And I would recommend you to look at it. As I was saying, I'm an Angular trainer. Maybe you recognize Todd Moto here in the picture. He wasn't an attendee. He was helping me out, just to not to bring wrong conclusions. And here last year, I mean, because I do a lot of conferences, I get to do other things. And this is a fun thing to do when I go to a conference. So I'm going to be the host. And then I've done a few conferences. You can see that's NG Europe earlier this year, DroidCon London, and look at the new generation of speakers. I mean, this guy is a plumber working on WebAssembly and just 22 years old. I mean, that's awesome. Of course, I also have time to do some side projects, and this is a fun one, NG Cruise, that happened last year. And this is also not Photoshop. This really happened. It was a cruise departing from Miami and going around the Bahamas for a week. This is proof of that. You can see some of the organizers, Tracy Lee, Joe Eames from NGConf, myself, and Taras from Elm. Some pictures. That was last year? How about this year? Oh, this year. Well, maybe if you want to come. Yes. The best thing, maybe it's not the right thing to show when you are at the conference. And but here you can see the venue. What about this venue? I mean, Microsoft is a nice venue, but look at this one. I also try to collaborate with other people in the community, and here you can see doing a collaboration with Angular Academy in Canada. And obviously, when I do these trainings, I also take advantage and travel a little bit. This is a small video we did at the end, just for fun. I mean, okay, that was a long intro. Sorry for that. So let's start with talking about motion. So why would you look into introducing motion in our apps? So I'm going to cover a few things, and probably the best that comes to my mind is giving a better user experience. And here you can see this is kind of a proof of concept that I'm going to work a little bit later. And here you can see, you can look at this recording, and it's kind of nice. You can see the animations going in, going out. You know, it's kind of easy on the eyes. And this is what most of the users will appreciate. There's another value when adding this type of animations and motion, which is improving the perceived performance. When the user looks at this animation, obviously it's kind of a trick. I mean, we know that nothing is happening here, but we show this as a placeholder. Then the user thinks, okay, something is going on, something is happening, so they get a nice experience. And you can see this being used more and more. If you want to go to another level, you can also use these kind of animations which are immersive. So what that means is that the interaction with the user is just changing the whole space here. So this is from Apple TV, and this is a cover from one of the movies. And as you move the mouse, it's just moving the whole cover, giving you this like 3D effect, which is completely like hooking you in, like, wow, what is that? And probably technically you are thinking, okay, how do they do this? I mean, you can do this with CSS. This is awesome. Other things that you can do with motion is improve the engagement with your users, and also promote your branding. So here, for example, Google uses this for the bootstrap. I mean, this is a boring time. There's a lot of things going on, and you use this animation just aligned with your branding. And also, it's kind of funny to look at these bubbles. I mean, look at this yellow ball. Okay, we'll look at it again. Look at this yellow ball for a while. Okay, this is appearing, now moving there. Oh, now it's bouncing. So you can look, I mean, of course there's so much going on that you can look a second time, a third time, and it's never boring. Another value from adding motion is, I mean, maybe it's too ambitious, maybe it's not like that, but it's kind of fun. It's getting the user happy. You need to use, you have to, or you're using the application every day. If you find these fun animations, it's kind of, you are kind of happy of looking at this. I'm not sure if you enjoy that, but it's a little touch. This is from Twitter. So let's see what principles are behind, because when you want to add motion to your application, you need to know some of these principles so it makes sense. It will just make a nice animation. So what are the principles when creating these animations? Well, usually the reference that people is giving away is this book from Disney, The Illusion of Life. And a lot of people uses this not only for web animations, but in general. So what principles are described in this book? So one of them is this squash and stretch that we can see on the top. If you look at this ball, you will see that there's some kind of, it's squashing. As it bounces, it just changes the size. And then just at the bottom, you can see the principle of anticipation. Anticipation is more or less like giving you an idea of what's going to happen next. So the ball is kind of holding it for a moment and then doing the jump. So it's a little bit nicer. One thing that you need to take into account when building your own animations is that you don't want to surprise the user, like changing states very quickly. So this anticipation will work very well. The other principle is this follow through. This adds some momentum. So imagine in this animation if the jump were to stop there without giving any motion. That would be really weird. So this one is exaggerating that follow through. The last one is making the motion really, really exaggerated. And this also gives us this like this comic feeling, like the bubbling top. But you can see that these animations can add value. Here we can see all of them, and this is a principle that we will use a lot. We will take one effect, and we will compose it with another one, and we will layer these animations one on top of the other. So here we can see these 3 animations, 3 effects at the top, and then all together in the resulting animation. Okay, so that was an intro. How we can do this with CSS? I mean, who can do those animations that I show in CSS? Who is able to do that? Probably not a lot of us. So let's see how we can learn these effects. So CSS animations, and there's no one better than the party parrot to do this. So we have 2 states. We have an initial state where the party parrot is very small, and then we have another one where the party parrot is also moving to the right and also increasing the size. And between these 2 states, what will happen, we will define these with keyframes, and the first one will be the 0%. That will be the beginning of our animation, and then 100% will be the end. And between these 2 states, we will just need to define the duration. With these instructions, the browser is going to create all of the intermediate states. And I want to focus on this aspect. So when defining animations, we instruct the browser to do a lot of work. Imagine if we have an animation of 2 seconds, the browser is going to be really busy calculating these intermediate states. It needs to change the position, it needs to change the size, it needs to change the scale, and that's going to be intensive on the CPU. So that's also one of the things that you need to take into account when building your animations. So let's see how that looks with CSS, and I'm looking into CSS animations. So we start with the name. That will be the name of the keyframe. Then we have the duration. We can also use a delay. And usually we will use the delay also to chain multiple animations together. So when one finishes, we can start the next one. We can also define this easing function. Sorry, no, that's the iteration. So iterations will tell how many times you want to run the animation. So we can also choose infinite. We can choose, for example, once, twice, or in the end, infinite. And then I was mentioning the timing, which is the easing function. Here, the linear function will be just, for example, if we are moving 100 pixels, half of the time we will be in 50 pixels. So it will be just a linear function, just half of the way. So that's how it works with CSS. And when we are using animations, we need to pick properties that we can animate. Not all of the properties are able to participate in an animation, and this is a list of all of them. One thing that I discourage you is to use all. That means that the browser is going to look into all of the properties in your element, and is going to animate all of them together. So imagine what a mess is that. One thing that you need to pick is properties that are very performant. And the ones that are very performant is opacity. That will be used for fading in and fading out elements, and transform. And I'm going to show you a few examples of how to use transform. But basically, if you are using these 2 properties, you are safe, at least in performance. We have many options for the timing function or easing. The most common one will be linear, but we have ease, ease in, ease out, and ease in, out. This will behave like this. So in the first example, the linear easing will be exactly like that. So for example, if we are moving an element from 0 pixels to 100 pixels, and we are at the middle of the duration, that will be 50 pixels. It's just a linear function. The other ones, mnemotechnic to remember what's going to happen. If you see the ease in, ease out, it's going to be a little bit more slow. For example, ease in, you can say slow in. Ease out will be slow out. So that will be a little bit slower at the beginning or at the end or it will start slow and end slow. And that have different effects visually. One concept that when building animations you need to take into account is the frames per second. So I wanted to show you all of them, like few examples. And this will change depending on your device. So if you have a really modern phone, probably will have more than 60 frames per second, but 60 frames per second is the number that in general is peak as a good reference. You can see, for example, 15, it looks like really jumpy, and 120, I mean, it's almost the same. You cannot even see the difference. And of course, that means that if we picked 120, that will be doubling the CPU usage. So that won't be that good. So 60 frames per second is just a nice number. So how that will work when running an animation? So this is you can do an easy calculation. So it's frames per second. So you can take a second, which is 1,000 milliseconds, divided by 60 milliseconds, and you have this magic number, 16.66 milliseconds. And this is kind of the window where the browser needs to draw the frame so it looks smooth. So that will look something like this. We receive an order to paint the frame, and the browser makes its job. And then we receive another order, and this is happening really fast. This is an example of a smooth path. So the animation or the drawing in the browser is really smooth, so we always have time to draw the frame that we intended to. Let's see what happens when we lose frames. So it took a little bit more time to paint the frame. We did paint the frame, but then in the second frame, we missed it. So that will repeat the last frame. And this looks, when we are looking at an animation, is kind of it stops, because it cannot paint the next frame. It just uses the last one. And that's when you see a janky animation. It's just stopping in the middle, and then you know that the browser is struggling to do its job. Of course, then it has some time to recover, and then it works as expected. One thing that you can see in this diagram is that we miss the triangle. So we just miss one of the frames. Maybe it was an important one. So let's see what techniques we can use for motion. So one of the simplest one is movement. So if we want to introduce movement, we will use transform, which is very performant, and we will use translate X. And in this example, I'm just showing this ball going into the center of this frame and going away. I'm going to use similar figures. So here, I'm showing an element that rotates, and I'm using rotate also from transform. And you can tell the browser how many turns. I mean, that will change the speed of this rotation. Maybe you can notice some of these frames being lost. Okay, no, it's smooth on the screen. So here we see another effect. This will be resizing, and that's using transform scale. So we have different options. Probably the most common that you will see is fading. So that will use opacity, and then you can pass a value from 0. It will make it transparent, or opacity 1 will make it appear again. Okay, so let's see how are you doing with CSS. This will be like a quick catch up. So I'm using few classes here just to kind of build on the different settings. The way it's going to work is going to apply the first class, and then it's going to aggregate the classes as I go from left to right. So here I'm using a base. I'm using this to define the base of the animation. Is going to use the move keyframe with a duration of 2 seconds, and is going to go on forever. One thing that we are going to use a lot in motion is we're going to introduce some cubic Bezier easing functions. That will give this bouncing effect that you can see. That makes the animation a little bit more smoother. Otherwise, it would look a little bit robotic. So that makes that little bounce in the middle. Here you can see how I'm using the keyframes to define the timing. So it starts outside of the site on the left side. That's the minus 250. And then it stops from the 40% to the 60%. That's depending on the total time, which is 2 seconds here. That's going to stop at these 50 pixels. And then it's going to run out until the end, until reaching these 2 seconds, just translating the same amount on the right. And the result is on what you can see here. So we did move. We can also see how we apply the same principles for rotation. Here I'm using a linear easing, so it just continues rotation. I can also use some shortcuts. So for example, before I use the percentages, now I can also use from and to. So to is going to be the 100%. And that's going to go for whatever properties had the element at the beginning to this rotation, which is 1 turn. That will make the full turn. We can use the same principles for resizing. So this is more like a pulsating effect. And you can also use this with keyframes. I'm just reusing the specification for these different keyframes, so I don't need to repeat those again and again. For fading, it was so boring that I also add movement to it, so it's a little bit more nicer. You can also see that I'm mixing 2 properties, 2 styles. I'm able to do the fading, but also the movement. It's beautiful. Okay, so how we do this with Angular? So let's move quickly into Angular. Angular gives us few tools. And one way that we build the animations is by using states and transitions. And that will work more or less like this. So we will introduce 2 states and the transition between them. And we can do this as many times as we need. You can see that we have 3 types of arrows. We have a single one-way arrow and also the 2-way arrow. That will mean the transition is not the same for each direction. If we have a single arrow, if it's double arrow, then that means that will be shared. So let's see an example with the fading animation. So we have this state. We are going to call it fade in with opacity 1. That will be the style for that state. And we are going to transition into a fade out, which will change the opacity to value 0. That will be the beginning and the end state. The browser is going to calculate, as we saw before, all the intermediate states. And it's going to use the total amount of the animation. The running time of the animation. Here you can see that it's 400 milliseconds and is using this linear easing function. And we will use this exactly like you see here in the code. One thing that we can do is the opposite. So if we are fading in from fade out to fade in, we can use exactly the same animation. So that will exactly do the same thing, moving from fade in to fade out or moving from fade out to fade in. One thing that we can do from this specification is just refactor it. We don't need to specify 2 transitions if they are using the same animation. So that's a little bit of intro. The code for this animation will be something like this. So we have our component using this add fade that will point to this fade trigger that we are going to define as part of the animations meta tag. And this will behave like this. Every time that I click on this button, it's going to toggle the state that this trigger is on. That will reference the animation, which is in an external file. And we start the state of this trigger with fade in. That will change the style to be opacity 1. Then every time we click, it will check the state that this animation is on, and will just reverse it. So that's kind of the logic behind this code. If we look at the animation definition, we start with defining this trigger, and we define the styles for the states that we define here. So we have a state fade in with opacity 1, and we do the same for fade out with opacity 0. So that's the starting and ending states. Then for the transition, I'm using the double arrow, so that will set the animation for both directions. And then I'm using just the same settings that I show you on the slide. So this is how it would translate with Angular. One thing that we need to remember is that Angular is using Web Animations API. And Web Animations API, they are very performant. So they are not as limited as when we use JavaScript with animations. One thing that we need to think about when using Angular animations is that the animations are static. We define the animations statically when we build the application, but we cannot run dynamic animations with that code that I showed you. One thing that we can do is create what is called dynamic animations. And I'm going to show you a demo, which I'm going to be moving the mouse, and I'm going to create a specific animation from the original initial position to the latest position of the mouse. So let's look at how that would work. Here we start with a template that will take the X and the Y, as you can see here. The moment that we have these coordinates, we will build the animation using that latest position, and then we will run the animation specifically for those coordinates. That will allow us to create the animation on the fly. And this is something that you cannot create with CSS. So this is specifically from Angular. So how that looks with code? Well, we need few things. We need the animation builder, which is the player behind these dynamic animations. We will use a couple of dependency injections. We are going to take a reference from the element and then also use the animation builder. Here I created a few helpers. So I'm going to pass the initial coordinates to this player move to. And within this function, I'm going to just create the animation. Here, I'm just creating an animation that moves the element from one coordinate to the new one. And I'm defining this second to run the animation to. I'm also using some parameters, so I can build the animation using the latest coordinates. The way I'm going to get the position is by using this reference to the element. So I'm going to use offset both for the new position and then calculate the difference between the last and the current coordinates. For this, we can also use from event from React.js. And then we will map the mouse move events with this function that creates the animation on the fly. So here I'm just getting a nice object with just the X and the Y coordinates. And then I use the subscribe just to call my player, build the animation, and then run it. So let's see a demo of this very quickly, how this works. So this is just to demonstrate. Is it awesome? I also create an event when I leave the page, so it fades out and then it fades in. It kind of comes back to chase me. Ah, so cool. Oh my God. Okay, so that was the intro to Angular animations with some dynamic animations as well. But let's go back to the motion design principles. So here, I'm going to introduce you a few of these principles. So I introduce you the animation principles, then these are the motion principles, and one of them, which is very common, is the easing. So here I will compare the linear easing with this bouncy easing. So you can see that the first animation, it looks like very robotic. I know, maybe you like the first one, but the second one is supposed to be better because it's using an easing. Another technique that we can use is this offset delay, and that gives you some visual cue on the hierarchy of these objects. So we can see that the first and the second, they are kind of primary objects, and the third one looks more like a secondary object. So you can use this principle to introduce it in your apps. We also have the parenting, and this is interesting because the movement is changing the size of one of the elements. So you can see that we can introduce some interesting concepts. Probably the most common in Angular is the binding values. So we can bind the value with the size of this object. There's also the overlay that we can see in a lot of applications. So let's see how we can apply motion. So the principles are pretty basic. So we go over an idea, then we see how we can apply the idea using the different styles. One thing that helps a lot is creating this story book with what will be the transitions from the elements, and then obviously the end result is the final animation. Using these concepts that I introduced, you can create amazing interactions like this one. So this one is using all of the principles together. This is actually CSS. And if you access my slides, you can click and follow the code. But one thing that is more interesting, I believe, is taking one example and adding motion. And this is what I want to do now. So let's look at this example. And this is a list that has a few features. So I can click on one of these squares, and it will remove it. There's some issue here because I click on the square, but it just seems that there's no cue which one has been removed or added. I don't know if they are coming from the top or coming from the end. And the same with remove. I don't know if I remove the first or the last one. So there are some issues. When I load this application, it also flashes. You will see that it just flashes the elements. Like there's no animation at the beginning of this. So let's see what we can do. One thing we can do is animate. When we introduce new items, we can animate that. And we have few keywords that we can use. When we, in Angular, when we add an item to a list, it's coming from what is called a void state, because it's not still on the template, going into an asterisk state, which is one of the states possible for that animation. Here, for that list that I show you, I'm going to use this stylus. So it's going to scale from the half of the element to scale 1. So it's going to start a little bit smaller, go to the full size, and it's also going to use opacity 0 to 1. So it's going to fade in. I'm going to use this transition, or I can also use this dash enter. So I'm going to use that to change that animation that I show you. Maybe let's change the code so it uses the animation. So here I can show you these triggers. I have a trigger for the list, I have a trigger for items, and I have this transition enter here. So let's add this. And I'm just adding the trigger to the element. So let's save that and see. Have you seen that now the elements are using that animation when they are rendered? They are just popping using that animation that I just created. And this is only used when I add the item. So that's working. The next effect that I want to cover is when I remove the items. So that's going to be exactly the same. I'm going to use the opposite transition. So now I'm going from one state to the void state, and I'm going to use just the reverse for that. Let me just uncomment these codes here. So that's the leaf. That's the leaf transition. And I faced some problems here. So here I had to add some kind of patch. Let me just show it to you how it behaves. So if I remove kind of a fix, this would be more or less what you expect. It's just the reverse of the, moving the styles from one state to the other, and that should work, but this is what you get. Oops, what happened there? Something is not smooth. So one thing that happened is I had to introduce few things. This style height with asterisk is going to calculate the height of that element, and the problem is because there's a space between the elements. If I don't calculate that space and I also animate that space to be decreasing, it's going to look like it's just jumping from one state to the other. And another trick that I had to use is this margin. Don't ask me why, but it's working. So now you get like this smooth animation. I mean, isn't that beautiful? So we covered both animations, when we add the element, when we remove the element. What else we can do? Well, we can do a few things more with Angular. We can change the execution order. We can use sequence or group to run in parallel or in sequence. We can also use one thing that is called dynamic selectors. So I can using a DOM like this, a container and a list of items, I can just pick the ones that I want to animate. So for example, I can use this in a very smart way, which is I'm picking the elements which I'm adding. And this will look something like a CSS selector plus this colon enter. So that will pick the new added items. I can also use composition. So I can mix animations. And this is something that is really powerful. And I'm going to demonstrate it now. And the last feature that I want to cover is this stagger. So what happens when I run the animations all together is like the visuals, they look a little bit strange. So for example, look at this. It just animates all of the items together. Let's see how we can improve that. Well, I'm going to use this other trigger that I defined, which is the list. And I'm going to use a transition which will pick the elements that are going into the template. And here I'm using a query selector, but I'm not using a class, I'm using an animation. So it's going to pick the items, which is a child trigger, and it's going to apply a stagger, which will escalate these animations with some delay, but also it's going to not decide what the animation is for the child, but it's going to tell the child component to animate. So you are delegating the animation to the child component. So you can create really complex animations using this technique. And this is the result. So once we show the list, we get the stagger, and we get these nice different animations. And now you can see that the interactivity is much clearer. When I'm removing the items using the button, I'm taking the items at the top. Or if I decide to click on an item, I can see which of the items is being removed. So we have used all of the principles. Hope you have enjoyed this talk. If you want to know more, you have a few influencers that I can recommend, and they inspired me on the different examples. There's also a few articles that I wrote about this if you want to know more. And yeah, that was all that I wanted to share.
So we have time for a few questions, if anybody has any. Looking for hands. There we go.
Hi. Well, I'm not sure if I'm misunderstanding the way that frames work in a browser versus like on the screen. But when I did traditional animation, we did 24 frames per second, and typically we doubled up the frames and they were 12 frames per second, which is lower than your lowest frames per second. And I was just wondering why that seems very smooth, but then the 15 frames per second example that you showed is very rigid.
I'm not sure. I mean, that would be exactly the the smoothness that you get, at least on usually mobile devices. I think on the browser, because we have much smooth like devices, they can handle much more. But I think the only limiting is the mobile. The mobile is kind of the lower end on capacity on the different displays. When you go to a laptop or desktop machine, I don't think there's any limitation there. That's also why we use some request animation frame which adapts to the device frames per second. So it could be higher. It's kind of dynamic. That will be handled automatically by Angular.
Hi. Did you suffer any issues with Angular Animations on iOS devices? Because as far as I know, Safari on iOS it limits to 30 frames per second.
There are some polyfills that you can use, but I'm not sure. I'm not able to confirm. I mean, I can send you some references to check, but I haven't tested. On those devices.
Because I had issues. Issues with iOS devices. I've been working on some project related to animations, and noticed that Safari on iOS always limits the frame rate to 30 frames per second, and maybe should we limit some animation amount for iPhones to keep the smooth experience?
As far as I know, Angular Animations are going to use Web Animations API, and Web Animations API, I'm sure it's changing the frame rates according to the device that is being used. So that should be covered. But if you want to know exactly, you need to look for Web Animations API compatibility for iOS.
So for a lot of projects at my company, the timelines are short, and sometimes we don't have time, or it's just cut out to get these animations. So what advice do you have as to adding the animations at the end versus, I mean, obviously you want to implement it throughout, but do you have any advice for kind of stacking it at the end?
The thing is, I'm just a developer that got into some research on for this, so I'm not actually a professional on animations. So I know the techniques, I know how you can implement some of the animations, but I don't have enough experience to give you some advice on, in large projects. What I would say is that you probably want to go into some kind of guidelines, like you want to define what would be, nice to be used. One thing that you can resort to is Angular Material. So Angular Material is a library that has, kind of guidelines, and also the components that are using those guidelines. So this is probably what you would do if you are going to use a library in your company. You're going to start deciding how much the animation should go through, like 400 milliseconds. You need to decide these numbers that will create the experience that you are going after. And then from these style guides, then you need to apply these to the different, the buttons, the selections, elements. And I mean, this is kind of a long project. I'm hoping that there will be more libraries, not only Angular Material, that will be popping up. But so far, the one that I know is Angular Material.
Thank you very much, Gerard. Thanks.
No worries. Cheers.